Yes? Okay, well, here's more bad news is it's not going anywhere. All that vocabulary we talked about, you need it this unit. And I don't know if you've had siblings, friends that have taken geometry before, but I'm sure they have told you a huge portion of this course is what's called proofs. Have we heard of those before? That's what we're going to start this unit. And I just want to warn everybody before I start today's notes. If something doesn't seem right or you don't understand it, get help immediately. Do not let it snowball in this unit. It's not going to be pretty. Do not let it snowball. Get help immediately. All right, we all clear? We can agree on that? Please get help immediately if it starts getting bad quick. All right? Here's what we're going to do. And this will lead us into our first proofs tomorrow and Friday. I am going to start giving you true information, probably with a vocabulary term from Unit 1 or a symbol like I have here. What you guys need to do is, oh, if he's given me that, then this conclusion must be true. All right? So everyone, take a look at example 1. I've given you a triangle, ABC. Quick reminder, what's that symbol right there? Perpendicular, right? Already. Isn't that a vocabulary term we talked over and over with last unit? Yes, it is. So perpendicular. If you know line segment AB and line segment BC are perpendicular, that's true. You should be able to give me a conclusion. You should. At this point, you should be able to give me a conclusion. What else is true about my diagram then? Can you think of something right now? I got a couple hands going. Based on what you remember from perpendicular last unit, can you tell me something true about the diagram? All right, more hands are going. More. Good. All right, I'll get back to one of you guys in a second. I need everything organized. I need all your thoughts organized. So how we're going to organize it through the entire unit and year is we're going to put it into 2 columns. All right, we're going to put this into 2 columns. Our first column is going to be our statements column. This is where we are going to put all the true facts. All right, that everything you put in the statements column better be true. And in the second column is what we're going to call our reasons column. Why is it true? Why is what you're writing in this statement true? How do you know that's true? All right, we are also going to organize it by numbers. So whatever statement number 1 is, reason number 1 will go with it. Why is statement number 1 true? Well, look at reason number 1, so we know they go together. All right, I'll start it off. What do I already know is true? The given. So the first thing I'm going to write in is AB is perpendicular to BC. I know that's true. Why do I know it's true? How do I know that's true? Go ahead, spat it out. What do you have? It's given. So that's exactly what we're going to write for the reason, because it's given. That is usually your first statement in reason, is the givens. Now you guys take over. Now you take over. If this is true, AB perpendicular to BC, you know what the definition of perpendicular is. What else is true on my diagram? Cal, let's roll.
Angle ABC is a right angle.
Awesome. Angle ABC is a right angle. Now take a look here, guys. You're going to see me start abbreviating in shorthand. Anything I do up here is you can do as well. But please do not do your own hieroglyphics. All right? Don't do your own shorthand. Whatever I use up here is fair game for you to use. Also, start marking your diagram for me, please. Okay, that's great that you wrote it in the statements. Start marking your diagram with what you're telling me as well. There's a right angle. All right, I know Callum knows why, because he wouldn't have gave it to me. How does he know why angle ABC is a right angle? What told him that? What told him ABC is a right angle? Let's roll. Via, what's up?
So it's because one of the angles is a 90-degree angle.
Well, how do I know that? How did I know to put that there? That's my question, everybody. How do I know it's a right angle? Don't say because it looks like it. That's never going to be a response in here. How do I know 100% confidence that ABC is a right angle? And don't tell me it doesn't because it looks like it. You want to refresh or no? Okay, that's fine. Scott?
Because A, B, and B, C are perpendicular.
What do from unit 1? What do perpendicular lines do? Form right angles. There you go. That's how you knew that was 90 degrees. So here's our reason. Perpendicular lines form what? Finish it. Perpendicular lines form. There you go. Guys, and that's just one vocabulary term, perpendicular. All right, ABC is a right angle. Perpendicular lines form right angles. And that's all, could you say that angle ABC equals 90 degrees? You could. I don't want you to get that too hardcore. Right here, this is what I need you to get out right there. Can you tell me it forms a right angle based on being perpendicular? All good, because I got a lot more vocab to throw at it. Questions here? One doesn't make you great, right? Let's get more. Cool, right off the bat, there's a vocabulary term. BD is the bisector of ABC. All right. Here's where I need you to be. If I tell you that, you got to give me a true fact back. All right, give me a conclusion back you know is 100% true. Organize your thoughts, get your statements, reasons, columns going. I'll do the same. Put your given in right away, because I know that's true. And the reason it's true is because it's given. Okay. And hey, there it is, bisector. The vocabulary from unit 1 doesn't go anywhere. Okay, look at my diagram. What should be true about my diagram? What should be true? You got to remember what bisectors mean, right? What did bisectors mean here? Bisectors. Get people going here. Carter, what do you got, big dog?
VA congruent to BC.
Those are rays, right? Rays can't be congruent to each other. What's getting bisected?
ABC.
The angle.
Yeah.
So I want two angles that are equal then. Not two rays, right?
Yeah.
That bisector's cutting the angle in half. So regroup. What two angles have to be equal?
ABP and DBC.
DBC. You good? You sure?
Yeah.
Don't call it BA because you see BA. That's just a ray, right? Not an angle. Mark it on your diagram. How? How do we mark angles congruent in this room? Those arc marks. Put them in. Put them in. Write it down and put it on your diagram. Congruent. Congruent. And please don't write R congruent. All right. Use the symbol. Use the symbol. Angle ABD congruent. Use it to angle DBC. Why? I know, and this is the toughest part, the why part. I get it. It's just going to take reps. Via why?
BD is the bisector of ABC, which means if it bisects, then it splits into two congruent angles.
I love that. The only thing I don't love, that's a heck of a lot to write. What he just said, right? What Via just said? That's a heck of a lot to write, right, Via?
Yeah, that's a lot to write.
Okay, so can I shorten it?
Yes.
What Via basically just told me was the definition of a bisector. That's what you told me, Via, right?
Yes.
That's what I'm going to write down. Okay, and that's fine. Definition, and if you want to abbreviate it, DEF of a bisector. Good job, Via. All right, you don't need to tell me a bisector splits it into two congruent angles. You're telling me the definition of a bisector, so leave it at that. Are we okay? I'm going to add in something else that maybe some of you aren't thinking about. But does everyone understand why these two angles are congruent? Because that's a bisector. All right, I'm going to add in something else that we're going to start using probably next week. See if you can. I'm going to write an incorrect statement that's not true. I want you to fix it and make it true. Ready? Angle ABD is equal to blank angle ABC. Okay, we know clearly those two angles aren't equal, the big one and the small one. Can anybody fix it, adjust it, add something to it? Zach?
Angle ABC is half. Sorry, ABD is half.
Thank you. Is half. Yes, half. Half. And in the same statement, I can also write, what other angle is half ABC? Angle. Go ahead, Zach. DBC. How did Zach know it was half? Why didn't he say a third? Keep it equal. A fourth. Scott. Definition of a bisector again. Not only does it cut it into two congruent angles, it cuts an angle in half. Perfect, everyone. Perfect, perfect. See how we're doing this now? Oh, I know what that vocabulary term means, so I'll mark it on my diagram, write it in my statements. I will work with you on the reasons. Don't worry. I know that's the most difficult and awkward part. Anything I can answer on 2? As you look at 3, what's the problem right away? Anybody see a problem on 3? What's your issue? Why are you so sad? What's the issue with 3? Oh, I'm so sorry. I didn't put a diagram there. So sorry, above average kids here. So sorry. So you're going to have to draw one. Okay, M is the midpoint of AB. You know how to draw a line segment AB, put M on there. And hey, even if you want to throw markings on there now, because you know what a midpoint is. Okay. What else is true? Maybe tell me what you marked on your diagram, or tell me what else is true here. Luke?
AM is congruent to MB.
Yep, what do I put on the AM and MB again? Not arc marks, but hash marks. Good. We'll write it right in here now. AM. Make sure, hey, I'm a big stickler for notation. AM, make sure we have the line segment symbol above, congruent to line segment symbol MB. What do you think I'm going to have for a reason, just based on what we did last problem? What do you think this one's going to be? Via, go ahead.
Definition of midpoint.
Thank you. Definition of a midpoint. I don't need the definition. You can just write definition of a midpoint. Now, will they all be definition of this, sometimes, but not always. And I'll make sure I go over with everybody when it's not acceptable to write definition of. I'm gonna write one more. You guys tell me. Yeah, I know those two are equal. Romeo.
AM is 1/2 of AB.
Correct. AM is half the length of AB, and I'll also write in the same statement that MB is a half of AB. And again, I know you guys don't realize it probably until next week why that's important. And then this would be why, Romeo, this is your statement. Why? Why is that true?
Definition of a midpoint.
Yep, midpoint cuts it into half, cuts a line segment in half. Anything I can answer before we get to this last one, which might be a little tougher? Anything? One more? Wow. How about that given? It's not much, is it? That WR and IE intersect. Thanks, Mr. Carlino. So I don't see any vocabulary term up there. That's going to help me. But I noticed the diagram. All right, I can see this diagram, and maybe you guys see some stuff we talked about from Unit 1 on that diagram. I hope. Before I ask somebody here, also, do not put in words that aren't there. Does anybody see the word bisects? Midpoint. So don't add it in. It's not there. It will never be there. Use the diagram here. The given just says they intersect. I don't see any vocabulary term there. So I need to rely on my knowledge of what's showing in that diagram. Does anybody see anything we talked about last unit in that diagram? Emma?
WR and EI intersect at point S.
Okay. I was going to try to get a little more than that. All right, a little more than that. I'm trying to get vocabulary from Unit 1. All right, vocab from Unit 1 here. There we go.
Angle WSI is vertical to angle ESR.
Everyone hear that term? Vertical, remember those? Okay, I'm not going to write that down because I'm going to go a step further. What do you know about them then if they're vertical? I don't need to say they're vertical, but I need to tell them you're what? They're what? Done. There it is. There it is, everybody. Angle WSI is congruent to its vertical angle, ESR. Put arc marks on those. Good. Okay, here's an instance where I'm not going to have you guys write definition of. Because if you say definition of vertical angles, ready? Here you go. What's the definition of a vertical angle? Two opposite angles that are formed by intersecting lines. Does my definition say anything about them being congruent? No, the definition does not. So instead, we're just going to say vertical angles are congruent. Okay, definition will not be appropriate here. And have some self-respect, please. Vertical, C-A-L, not C-L-E. We're good. Okay. Isn't there another pair of verticals up here too? Okay, so I'm going to put that in the same one. Ready? ISR is congruent to angle WSE. Now, I don't think I ever went over this with you in Unit 1. How do I mark that on my diagram? Because if I just put a single arc mark, it's going to look like all four are equal, right? Lisa, got a suggestion? Yeah, put 2 instead, right? Because if I just put, hey, take a look. If I just do this, that means all 4 are congruent. All right, but they're not. So I'll put double arc marks to show that those are equal. Good, guys, good. And I'm going to need one more here. I got verts up there. I know I got verts. I see it. Callum, go.
WSE and WSI are a linear pair.
They are. Keep going. What's that mean then? You don't need to write that they're linear pair. Go this step. Thank you. What word did he just use again? Supplementary. WSE and angle WSI are supplementary. Oh boy. There's no I in supplementary, everyone. No I in supplementary. And I realized, and let's just save ourselves some writing and time. I know I could put other pairs are supplementary. We all agree there? Other than those two? I don't want to write all that though. Let's just keep these two. Okay, why are they supplementary? I'm going to look for something specific. So you may tell me something correct, but I need something specific. I want why they're supplementary. Scott? How do you know that? Well, that's why you're saying they equal 180. That's basically what you're saying there. Why do they equal 180? Like, how do I know it's 180? How do I know it's not 90, 76, 82? Okay, you see a straight line, right? Let's keep going. That's correct. I want more though. And I don't know if anybody was listening to Callum, but he actually said the vocabulary term I was looking for. These two do form a straight line. They are also via?
They're also intersecting.
They don't they're next to each other. They don't intersect. Jackson, come on. What's that? One more time. They're linear pairs, aren't they? And what do you know? If two angles are linear pairs, they are supplementary. Okay? Linear pairs are supplementary. 9 times out of 10, everyone, that's going to be your reason for when you tell me angles are supplementary. Okay, that they're linear pairs. All right? 9 times out of 10. All right, linear pairs or supplementary will always be your reason. So you see what we're trying to do here. Use what I give you to produce more information. Here's my requirement on homework. You have to have at least one more statement than the given tonight. If you have more, that's fine. But if you just have the given, that's not going to fly with me. All right, you need at least one more statement other than the given. And before you move on, because this happens every year, so I want to eliminate the possibility right now. Go to number 5. Okay? It says H and M are supplementary angles. So what do you know about H and M? If they're supplementary. They add up to 180. Do you guys see the word perpendicular anywhere? Me neither. I'm trying to tell you that you cannot, just based on the diagram alone, tell me H and M are right angles because it looks like it. Baloney. Baloney. Okay, unless you see the term perpendicular somewhere, you cannot tell me they're right angles. Because look, angle H could be 100 degrees. Angle M could be 80. Are they still supplementary? Yeah. So they're not both 90. So please don't put that in your statements. Okay. All right. See what you can do. Call me over if you have questions. Because tomorrow we start the big stuff with proofs.